Hey guys, welcome back. Today we are reviewing
the Yixiang version 2
48 volt DIY battery kit. In the previous video we did some stress testing on the components of the version 1 kit and found the circuit breaker to be insufficient. This box is supposed to have an upgraded beefy circuit breaker as well as some enhanced safety features. Let's get started. EVA tape for the PCBs. I like it already.
User manual.
Holy crap!
Okay, so I got the version 1 white box on the left and the version 2 box on the right, so we can compare them directly side by side. So let's first take a look at the battery terminals. We got the same M8 style battery terminals. We got 2 positive and 2 negative for easy paralleling. They do come with these covers. These ones came not installed, so they're probably in the box, but there's a trick to getting this off. So you do not want to pull directly out. You want to pull up, but more so you want to twist clockwise. So if you give it a twist, it'll pop right off. But if you just try to pull it out, you'll have a hell of a time. So just remember, pull and twist, or twist and pull really, and it comes right off. Other than that, everything else is pretty much the same. We got the same design, power switches in the middle, got your BMS down here, all our ports. We got our dip switches, run, alarm, state of charge, dry contact, RS4851, CAN, RS232, and RS485 number 2. The grounding lug is the same, it has not changed. Moving on to the circuit breaker, you'll notice this huge 250 amp DC rated bidirectional circuit breaker. That's important, we'll cover that later. Over here on the version 1 box, we got this little rinky-dink 220 amp switch breaker. Does work though, I have tested it in the previous video. But the main issue is this is 250 amp rated and this is 220 amp rated. So we have 200 amp BMS in these batteries. If you're pulling 200 amps, an 80% duty cycle on the breaker would be, you would need 250 amps. 80% of 250 is 200 amps. Over here we have 220, so that's insufficient at 80% duty cycle. I will cover the bidirectional breaker a little bit further on in the video. Okay, moving on to the side of the box. Version 1 box is completely covered. There are no ventilation holes. Here they have added ventilation holes, and that's because there is a fire extinguishing aerosol built inside the box. We'll cover that later. As far as the side latches are concerned, they're exactly the same. The handles are exactly the same, so no changes there. And looking at the other side, we have our ventilation holes again. So we got vent holes on both sides of the case. Looking at the back of the box, no changes there. Okay, let's talk about the casters real quick. You can get these casters optionally. They're 40 bucks extra, but they can only handle about 3 boxes added on top of them. I've been using these dollies and they work great. I recommend using these over the casters. The metal where the caster mounts to the actual box starts to break down and bend. So what these companies are now doing is building these carts. They're getting away from the casters and they're just using these carts instead. So about the bidirectional breaker, the reason why that's important, because in a solar system you're either charging or discharging the battery. So the current is actually flowing either direction. So the breaker will still work in any direction. Also, if you had an internal short in one of your batteries, all the other batteries in your battery bank will dump into that single battery. That's where the bidirectional circuit breaker is useful. Let's get it on the bench. So I noticed that when I was removing the cover to the box, the screws are a bit larger. So this is the larger version 2 screw, and this is the old style version 1 screw. So it's the same threads. The head on the version 2 screw is larger, and it's about 2 millimeters longer. Same thickness on the threads. I also want to quickly show you the user manual. We'll cover this more during the build video. So I'll be shooting this shot wide angle so we can see the entire box overhead. So there'll be a bit of a fisheye going on, so that's what that is. The box is not bent. Alright, so here's the BMS accessories. Everything comes just like this, how you see it shipped, very nicely packed. Alright, let's check out what we got in the box. We got our bus bars, of course. These are the flexible red copper bus bars, double hole studs. These ones go on the cells. And we got our big aluminum. They gave me an aluminum one. What? I'm gonna have to complain about that. I have a spare from another battery, but this should be copper too. What the heck? This is the bridge bus bar. This goes between the two 24-volt packs on either side. It's really annoying. And we got the serrated head M6 stud bolts, so that's really great. We don't have to worry about these getting up to 200 degrees. Please see the previous video about that. We got our comms cable and zip tie, and we got our external battery terminal covers. Somebody messed up on this. This is not even flexible. It's got the, what the heck? It's got the ridge as if it were, right? But it's not even totally rigid, so what? I'll be talking to Becky about that. Okay, so this is the copper bridge bus bar. This is the only one I've ever gotten, was the copper one. So I have no idea why they sent me this janky little aluminum one. Very much lighter. So yeah, hopefully this is a one-off thing and they just, I don't know, screwed up. But I'll ask Becky about that, and yeah, so still some consistency issues. All right, well, let's remove the PCB boards. Can't see what the hell I'm doing over there. Okay. Finally. All right, so we'll talk about these later. For now, I just want to continue showing the inside of the box. Here we have our epoxy board and our EVA tape. This epoxy board is definitely thinner, I can tell that. Here's the old board from the version 1 box. You can see through this. Okay, moving on to the fire extinguishing aerosol. This is the sensor lead. And what you'll do, we'll cover this in the build video. You want this to cover as much surface area as possible. So you're going to wrap it around all the cells, on top of the cells. You want to contact as much surface area as possible so it can detect any fire. So this works on flame. It detects the flame, and I believe it triggers at 350 degrees Fahrenheit. I'll put a picture here that shows the model number. This actually feels very fuse-like. Yeah, it's like feels like, you know, those old firecrackers, like a paper on the outside. It's a bit squishy. I don't want to trigger it. This thing emits at the rate of 100 grams per meter cubed, it looks like. Anyway, don't want to be near that when it goes off. Yeah, so Yixiang sent me a sneak peek video of the fire aerosol extinguisher in action during testing. Let's take a look. That was pretty cool, right? So we saw the operator had to actually go and physically ignite the fumes coming off the LFP cells. That's because LFP cells are not directly combustible. They do not have thermal runaway, so they cannot self-combust. But there has to be an ignition source nearby. Now, one thing I noticed is all the fumes did not ignite. We saw the whole room was filled with the smoke, but only the smoke directly near the battery ignited into flame, and then the aerosol extinguished it really fast. It's only one and done, so once it's done,
it's done. If you have an ignition source that can't be put out near the battery, it could ignite again. So don't build your battery bank near an ignition source. LFP is considered to be one of the safest chemistries on the market. That's why everyone uses them. However, it's worth educating yourself about potential risks. So in the description below, I included a video I found that I thought was really interesting about some events that happened with LFP cells. So please go ahead and watch that. Basically, it speaks to not allowing the fumes to build up in a confined space. That's where a potential problem could occur. So check it out. Let's take a look at the PCB boards. Version 1. Version 2. The first thing you may notice, if you look close, we have a completely redesigned PCB board. Finally! No more tape, no more insulating your screws, and no more screws with washers that can potentially short out your BMS. Look at the heads, they're smaller, and there's no washer. FDC 48 volt 300 JH. So I think this was more of a generic PCB that many manufacturers were using. But Yixiang, check this out. Yixiang 48300 A01, and A01 represents, typically on PCBs, the first revision of a board. I'm assuming this is Yixiang's proprietary design. These solder joints have been covered with glue. This is something I complained about in the version 1 PCB. All the solder joints are exposed. So that's a very nice touch. You can see the traces are completely redesigned to avoid the screws. Now they only still include 3 screws. I believe it's one here, and one here. But there's plenty of room when the screws are actually down into the PCB board. So that's best case scenario. And it looks like that's worst case scenario. However, they do not include a screw in this particular location. So make sure you're using screw holes to avoid the traces. Version 2, you'll notice if you press down, there's no give. Well, a little bit, that's because it's not mounted. But on the version 1, if we press down, look at that. Whoa, bad. There was no support underneath the PCB. Where the connector, where you're plugging in the connector all the time, you could potentially weaken the PCB. You'll notice on this one, they put a pad here. So it's completely supported underneath the connector. And they insulated with glue as well on the back side of the connector. Alright, let's take a look at the back side of the PCB. So we're flipping over version 1 here, flipping over version 2. Now look at these screw holes, look at the difference. Look how close this is to the trace. Look how far away it is from this one. Same here. And same over here. Now could they have optimized this? Yeah, sure they could have. I don't know why you have to have these huge, massive traces, but I'm sure they have their reason. But at least we got finally a new designed PCB, so that's great. Taking a look at the B board, just a quick side-by-side. Everything we saw on the A board pretty much exists on the B board. Last thing, the EVA tape. If we flip this board over, nope, no EVA tape there. It's not here either. Where is it? Where's the EVA tape? It's on the back of the it's on the back of the rail. Like, what is the point of that? The whole point of the EVA tape is supposed to go underneath the PCB to protect it from touching the metal. What's up with that?
Now you're probably wondering, but Nate, you got EVA tape right here, just stick it on the PCB board. I forgot that I actually told Becky that I need EVA tape for the version 1 box. These do not come with the version 2 box. Whatever's on the back of that rail is what you get. So these are extra, you won't get these. There's no EVA tape underneath the PCBs.
Okay, let's pull off the faceplate and look at the internals. Yeah, you don't want to come off.
Alright, so it looks like this cable is holding the faceplate from coming down. So we're going to have to remove that one. And there it goes. Okay, so the first thing, let's talk about these battery cables. The P positive coming off the breaker, the P positive going to the battery positive terminals, and the P minus coming from the BMS, and also the battery minus coming from the other side of the BMS. All the cables, 1, 2, 3, 4. So early versions of the box came with these battery cables, and these battery cables were found to be insufficient. Now you will either get a supplemental box of copper bus bars to replace the cables with, or the box will already have the bus bars pre-installed. I got the supplemental box. Let's take a look. So I was looking through these. Look what I found. I found the copper bridge bus bar, so they actually sent it in the box. So you'll have 1, 2, 3, 4. So here's everything I got. We'll replace these during the battery build video. This image shows the bus bars installed. Here we can see the instructions on how to install the bus bars. Alright, so the first thing I want to look at is this monster circuit breaker. Look how huge this thing is. It's like 6 inches long and 1.5 inches wide. But look how big these screws are. I was looking at these screws, they practically touch the pressure plate. There's like a 1/4 inch of space. That makes me nervous. I want to take a look underneath this epoxy board just to show you the hardware they used to put this thing together. There's these 6 massive screws here. You can see how big the lugs are for the battery cables. So plenty of contact area for the battery cables. So just like in previous boxes, we've seen these spinning knobs here. Looks like they still like to use those. I guess if it works, don't change it, even though it looks ugly. Actually, the white box that I have these little tabs. I'll put a picture up. These nice little tabs that just clamp it in. I don't know why they just don't stick with that. Looks like they're using M6 screws and lugs for the main connection to the battery positive and battery negative. It looks like a pretty good size, so I think it can definitely handle 200 amps. Just by the looks of it. Looks like they're putting the entire cable still in the battery box, so. Comms board is still in the same place. Pretty much everything's the same except for this massive breaker over here. Make sure when you get this box that you open it up and check all your connections, especially the main battery terminal connections up here and your comms connections over here on the comms board. Okay, let's remove the faceplate and take a look at the pressure plate and the BMS. Let's disconnect our comms cables here carefully. Don't forget our display. Looking at the BMS, first thing I noticed is they put heat shrink wrap over the inductor here. I'm not sure what this could be for, either RF shielding or most likely they just want to protect the coil from rubbing against this outer plate here. Anyway, same as usual. I think this is a newer BMS version. I'm going to have to check the app and see what version I got. It'd be really cool if it's a version 19, but I don't think so. It's probably somewhere in between. Anyway, we got our typical battery positive or power for the BMS. This goes on your main battery positive. Our comms cables over here, display cable here, and over here we have our balance leads. So make sure that these are all secure when you receive the box. Per usual, we have our 6 M6 bolts holding our pressure plate to the case. Look how long this thing is. Jeez. I really like this hardware that they give you. The stainless steel bolts are about 1.5 inches long. That allows for a lot of adjustments, so you can have a lot of different cells in this box. Accommodates a lot of different
cell manufacturers. And there's the plate. Not much to look at. With the faceplate removed, so you can see inside the box, you can see I put the bolts back where the faceplate mounts to the chassis. So you can see that really clearly. Got our middle rail here, our two side rails here. I wanted to do a quick overhead shot of the BMS on the faceplate. And should I remove the BMS? Sure, why not? You guys are so convincing. Now, if you guys have been watching my videos for any length of time, you probably noticed I never use any power tools. I have a pet peeve with power tools on things like this. I'll use them in places where they definitely have a need, have a purpose, but when it comes to like small electronics, I don't know, I just believe there's nothing better than the good old feel of the hand, basically. Probably because when I was a kid I was poor and I couldn't afford power tools. It looks like we have the PB2A16S20P. So that's 2 amp, 16S, 200 amps output. 200 amps continuous, 2 amp active balancer, 350 amps max surge. And look, it'll actually do 8S to 16S. You could actually use this on an 8S pack, a 24 volt pack. Alright, let's scan this real quick, see what we get. It's probably just going to take me to the documentation website. Oh, check it out, 2018 to 2021. Yeah, so that's just the website to download the app and the manual. So I was hoping to get the version number. These logs definitely seem sufficient for 200 amps. So I'm really curious now. These are 125 degrees Celsius insulated, just like the cables on the version 1 box. I don't know what size they are, but they're doubled up. It could be 4/0. If that's the case, if they are 4/0 times 2, then technically with this insulation it may be able to, we may have to actually test these cables. They're not used in the boxes, so I don't know if it's even worth testing. But maybe if I'm bored I'll do it. So it looks like Yixiang's primary focus this time around was safety, and I think that's a step in the right direction. Personally, I like to have multiple layers of protection, so I have the breaker that's built in the box, and I also like to add terminal fuses. And here's what the terminal fuse looks like when it's installed on the battery terminal. So the fuse holder will mount right to the terminal, and then your fuse installs onto the fuse holder. With the terminal mount fuse, the entire battery cable going from the battery all the way to the bus bar is protected. These fuses are made by Blue Sea and are marine rated and have an AIC value of 2000 amps. Link below. So Becky told me there are a few of the version 2 boxes still in the US warehouse. They also have a gray box, but it's China order only. Prices on Alibaba will be for the box only, will not include shipping, and will not include the price of the cells. Be sure to ask Becky about the cells, what manufacturer you want and what capacity you want. They carry all the brands that I listed earlier in the video. If you're going to order from China, the easiest way to do it is to click on the link, the Alibaba link I provided in the description below. You can also check my website for more details. Link below. So overall, I give this box a 5 out of 5. I think there's very few things they could do to really improve it. It's just minor, like the EVA tape under the PCB, just stuff like that. But as far as the hardware and the construction, all the fastening hardware, the screws and bolts, and the construction of the box, I think it's really good. That's it. That's all I got for this video. Thanks for watching, and I'll see you on the next one. If you can't wait for the next video, check out this one right here.